Okay, hello, welcome everyone. In this video, I'm going to be talking about personality types in the robotics classroom. My name is Perfect Patel, and I am doing this presentation as a project in a course at the College of New Jersey's Regional Training Center called Teaching Styles and Personality Types in the Classroom with Professor Dan Rendine. And so, what sort of inspired this project is if you look at most robotics platform kits that are made by like Lego or Vex, or if you look at curriculum that is written in robotics, it's usually centered around some type of competition or sports, whether it's robot soccer or placing tennis balls into a goal or anything like that, right? And so in quotations there, you see expanding beyond robot sports. Not that those things aren't valuable, but maybe looking at ways we can be a little bit more inclusive to all personality types and intelligences as we go here too. What's useful if for this session is if you do a bit of pre-class homework, if you're able to bring 6 to 8 samples of student design portfolio work from different projects, and try to bring a range of work that of grades that are A's and B's and C's, D's and F's. Um, we can it'll be useful for analysis tasks later. I think if you are a technology, robotics, STEM teacher, your main method of assessment is to keep design portfolios to track progress. If you don't have these things, you're a new teacher, you can click here and it will take you to a website where I keep digital copies of some of my students' portfolio work. So this is for a CO2 car project, right? And then I have other ones here. So if you could bring in like 6 to 8 different project portfolios, that'd be good. The essential questions for this presentation are: what are different student personality types? How do common robotics projects or learning units cater to different personalities? How can we design robotics projects or learning units to better reach all types of personalities? And so our broader questions are outlined there. According to a book called True Colors, people people's behaviors tend to fall into 4 main categories of personality types, and they've organized those into colors, which are orange, gold, green, and blue. Um, so very broadly, quickly defining it, people who exhibit orange behaviors are energetic, spontaneous, charming. People who exhibit gold behaviors are punctual, organized, precise. People who exhibit analytical, intuitive, visionary behavior are green. And in the heart here, we have people who are blue. They may be empathetic, more empathetic, compassionate, and cooperative. So if we were doing this live, I'd do an activity with you, a guided discussion, and the directions would be: think about about personality type colors. Based on what you know about your students and their design portfolio work, which colors do you think excel at different parts of the design process? And I would give you a pack of M&Ms, and I would print this out, and I would ask you to cast a vote. Right? I think everyone here, as a technology, robotics teacher, STEM teacher, You probably use some version of the design process or design thinking process, and some of them have more steps than others. But we know that the main 5 steps are to kind of empathize with people, understand the problem, then define and set some goals of how to solve that problem. All right, and then to ideate, sketch, draw, think of ideas, communicate ideas, then to prototype by building, with materials, tools, glue, poster board, wood, etc., and then to test that problem, right? So we know the major stages of the design process, regardless of which one in particular you use. So look back through your portfolio work and maybe flip back to this slide and think about which colors tend to excel at different stages of this process better, right? So if you think greens, we're pretty good at the testing phase. You can put a green M&M there. If you think that oranges are good at the defining stage, put an M&M there. It'd be interesting to see how spread apart our M&Ms were. I think if we did this live, I think we would see similar distribution to this, right? In my teaching experience, I've found that different colors are good at different stages of the project, and other colors are hesitant to complete other stages of the project. But in terms of global population, the book says that 35% of people are gold, 27% are orange, 23% are green, and 15% are blue. Um, from our class, of 23 teachers, many teachers were gold, and I think our distributions were similar here. Um, what's interesting to me is that gold, which tends to be punctual, organized, precise, um, and orange, which is energetic, spontaneous, charming, are somewhat opposite. But these are the two dominant colors. Almost 2/3 fall into these categories. So sometimes in classes we have a divide between people who want to do things theoretically and people who want to do things practically, or just jump right into problems. But it's useful, I guess, in lesson planning and design to think about globally what different colors and personality types are as far as numbers. So in the robotics and tech classroom, and I think most people agree, what I found is that orange people usually love the hands-on part of design. Usually quick to finish building, do not always do not always follow the safety rules. Just want to keep working, get it done, keep it simple, and they enjoy the competitive aspect, right? Build the fastest car, build the strongest robot, build the tallest tower. Um, and so they tend to excel at the prototyping phase. My experience as a technology teacher, and you can confirm or disprove this by looking at your design portfolios and reflecting on your own practice. Golds are like the planning and ideate stage. Um, they tend to be drafters or CAD operators who enjoy precision and measured lines. They're making the Gantt charts to make sure things are on schedule, making lists. What I see in classes is that they rush in order to get things done, so that they can stay on schedule. And sometimes they overlook opportunities to make one aspect of the project better for the sake of time. Um, you know, I think all of us know as tech, robotics, STEM teachers that projects don't always have a linear progression. There's actually data out there that says that in project problem-based, design-based learning, it's actually a big squiggle. There's a big squiggle struggle, of understanding. Then at the end, there's a solution to a problem or design challenge, and this can frustrate them.